begins by looking at the basic float data type. Now, float allows us to store and perform mathematical operations with real numbers, the same as int and long, who allow us to do it with integers. The way you do float operations is you declare a float box here and a named variable is being defined and float is being used to specify the size of the box. And then you scan this A using the placeholder %f, and you can print it again using the placeholder %f, and bingo, you know how to work with floats. You can see that the syntax is exactly the same as if we were working with ints, but the difference is that you can now store float values which are real numbers, not integers. Now, float has a very large range, much bigger than int. This is for a reason that we'll get to when we try to understand how decimal numbers are actually represented in binary code, and we'll look at how float is implemented under the hood, but we'll not do that in this video. This video is primarily concerned just with the practical application of how to work with floats, scanning them, printing them, and doing operations with them. Now, arithmetic operations apply to float just as well as integers, with one exception. You will see that the modulus sign, the percentage sign, is missing here. Why? Because there's no concept of remainders when you're working with decimal numbers. There's no decimal number remainder, that it just divides exactly. And so here the division operator becomes its true meaning. It's an exact division, not a quotient that is being generated as we were doing with ints. When you want to store and print a float or a double, then you get to use either of these placeholders, and they are interchangeable. They mean the same to the computer. So we'll talk about double on the next slide, but for now, just be aware that when you're trying to print a double, you can also use the placeholder %f. For long double, which is double the size of double, you have to use the placeholder %LF. And you can also use the special placeholder %E if you want your answer to be printed in exponential notation, which is very useful when you're trying to print huge numbers. So here's an example. I have specified a double variable called A, and I've assigned it the value 123.4567. Now I can print it out, and what I'll get is the value of A is 123.456700. This is the way float works by default. But what you can also do is you can print this out using exponential notation. And in this case, what you will get is 1.234567 to the power 10 times 10 to the power 2, which is correct. But again, this looks very ungainly still. Can we round up the decimals so that we don't see too many of them? Yes, we can. And this can be done, surprisingly, by using the placeholder. So look at what's happening here. We are saying, instead of saying %f, we will say %0.2f. Now, the meaning of the 0 we'll talk about in another video, but for now, just be aware that if you want to print to 2 decimal places, you'll say %0.2f. If you want to print to 1 decimal place, you'll say %0.1f, and so on. And when you try to do this, the compiler is going to tell the computer to only print up to 2 decimal places, and this can be done both for regular floats and also for exponential notation printing of floats. In this case, you will again see that the value that is being printed is truncated after the second decimal place. Something to keep in mind is that the computer is not truncating the the output at the second decimal place. It is actually mathematically rounding the answer correct to 2 decimal places. And the standard rules of rounding apply, where if the digit that is to be rounded is less than 5, then it is rounded down, and if it is greater than or equal to 5, then it is rounded up. So this is how you print floats. And now let's look at how we can print these numbers in displays that we can control with a little bit more precision. But we won't do that in this video. We will do that in a different video.